Saxon Algebra 1, Lesson 43. Oh my gosh, here we are again. I'm so excited to be here. Christmas is coming, at least at the time I'm saying this, and I'm getting kind of excited, you guys. I'm not excited to be done with math, but I'm excited to make progress and put the fall behind us and decorate Christmas trees and eat some cookies. So let's get our math done and get to the other stuff too. All right, we're going to talk about the least common multiple today, but before we start that, I'm going to talk about the least common multiple's best friend, and they're kind of like identical twins in that everyone confuses them with each other. Greatest common factor and least common multiple are forever being confused. Greatest common factor is when we have an expression like 2x plus 10, and we would say the greatest common factor is 2. It is the largest value. I'm going to put words to it, and you know how that always limits things. The greatest common factor is the largest value that can be divided out of both numbers, right? So we look at this and go, oh, we can pull a 2 from both of them. So we factor out the 2. And sometimes that helps. We factor out to find the greatest common factor. Now, how is that different than a least common multiple? A least common multiple is when we're trying to add something like 1/2 plus 1/10. You know a lot about least common multiples. This is not a new topic today. We're just going to use it in a different way. Least common multiple is when we look at these two and say, what is the lowest number, the smallest number, that both of these can be multiplied into, right? Because we're going to have to adjust up. And in these, we would say, oh, the LCM is 10, right? Because we can multiply this by 5 over 5, and then they'll both have denominators of 10, and it'll be great, right? So the LCM is the smallest value that both numbers multiply into. Okay, 10 is the lowest number. Now, we could have used as an LCM, although it really wouldn't be an L, it would just be a CM. We could use 2,000, right? 2 goes into 2,000 and 10 goes into 2,000. It's a common multiple, but it's not the least or lowest common multiple. And that just makes us crazy. We want to choose the smallest number possible. So even though we could choose 2,000 or 2 million or 2 trillion, no. We want to choose the lowest one possible. Okay, so that's the difference. One has to do with pulling out the smallest thing that they share in common. One has to do with making them both the same size, or finding the number that they both multiply up to. It helps to remember that M stands for multiply and the F stands for factoring. Okay? So again, people get confused because they forget which name goes with which operation. I want you to know the names of them, but I also want you to just remember the idea behind it. Okay, so how are we going to use this today? And why am I rehashing all this? Let me flip you. This becomes a super useful operation for problems like 43.1. Are you ready? It says find the least common multiple, LCM, of 8, 15, and 100. So let me write those numbers down. 8, 15, and 100. So what we're saying is we want to find a number that all three of these guys can multiply up into. Remember, the LCM stands for multiply. The GCF reminds us to factor. So we want to find the number that these will all multiply up into. The best way to do that is to use my favorite, prime factor trees. With cute little numbers like 2 and 10, we don't need a tool. We can just look at them and figure it out in our heads. But I don't know off the top of my head what number 8, 15, and 100 will all multiply up into. So this is what works. Let's do prime factor trees. Remember, we pick any two numbers that multiply, and we ask ourselves, is anything prime here? Well, 2 is prime. And this breaks down to another pair of 2's. So we can rewrite 8 as a product of prime factors. Okay, we're not done yet, but that's really helpful. 15, 3 and 5 is the only thing I can think of, and those are both prime. 100, 4 times 25 is what jumps into my head. It doesn't matter which pairs you choose first. If we're all breaking down correctly, we'll end up with the same prime factors in the end. This was 3 times 5. And this becomes 2, 2, 5, 5, right? Okay, so then I can write these down. And I like to write everything in order because it keeps me super organized. Because now what I have to do is I have to collect up. I always think of it as berry picking. I know that's weird, but you know those like wooden berry boxes? The sides are made out of thin wood and they're kind of nailed together. I always think of those, and I think that what we have to do is we have to pick these number berries, and we have to make sure that every single one of these numbers can find itself in the collection. And I'll tell you what I mean by that. We start with the first number and we just list all of its prime factors. We start with that. Now we go to the second number and say, okay, are any of these numbers already on our list? Better to look here. No, there's no 3s, no 5s, so we have to add both. Now we look here. Are any of these numbers already on our list? Yeah, we already have 2s. We have 2 2s. And we have 1 5, but we need to add 1 more 5. All right? So it's not that we need to have all these numbers in the least common multiple, but each one of these can be found one at a time, right? So the fact that we're using 3 2s here, okay, so that number is good. Now we can look at this number. Yeah, he's good. See what I mean? So now we've picked all the berries we need. We've put them in this basket, and now what we have to do is multiply and make this into a beautiful number. That's going to be 10. That's going to be 10. And that's going to be 6. So I can write 6 times 10 times 10 equals 600 is the least common multiple of 8, 15, and 100. That's pretty useful. Pretty dang useful for figuring things out. All right, let's do it again down here. 43.2. Find the least common multiple of 30, 75, and 80. 30, 75, and 80. If we were working together in the same physical space, I would say, or even talking to each other, I would say, okay, I'll do one, you do the other. But I have to do them all. It's kind of sad, isn't it? 3 times 10 pops into my head. 3 is prime. 10 goes to 2 and 5. So I've got 2 times 3 times 5. If we stay organized, it makes it a lot easier to collect your berries and go through that process. That's why I prefer it. 75 is 3 times 25. Circle the prime. And I'm sort of squished for space. That's why I'm sort of going sideways. This one is 3 times 5 times 5. I get excited. Okay, there's a 5 in common. There's a 3 in common. And then 80 is 8 times 10. Now, 8 I have memorized. It's 2 times 2 times 2. So I don't need to show the 4 and then break that down. That's silly. If you know some of these, like that one, just do it the fast way, as long as you're right. This one is, boy, 2 times 2 times 2 times 2 times 5, right? 1, 2, 3, 4, 5. It's a little bit of extra work to write them down like this, but it's a lot easier than trying to look through all these jumbly bumbles and trying to make sure you've picked the berries properly. So that's my advice. Okay, we always start the first one, just copy it as is. And what I do is I leave some blanks in there so that if I need to add another 2 or some 3s, I can do that. Okay, this one's good. Now I go here. Okay, I've got the 3, I've got 1 5, I need another 5. Now over here, oh man, I gotta break loose with the 2s, don't I? 1, 2, 3, 4, I've only got 1, so I need to add 3 more, and I am squishing them. 4 2s, 1 3, 2 5s. All right. Let's connect the 2s and the 5s because they make 10, and that makes life easy. All right, and then this little clump is left. 2 times 2 times 3, that's 12. So my answer is, let's see, I have 12 times 10 times 10, right? Because these bundles make 10. This isn't the way you have to simplify. It's the way my brain likes to do it, so I'm showing you as an option. What's important is that you follow your natural intuitions, and I'm assuming you have them, about how to combine these numbers. When I see 2s and 5s, I think, boom, let's make 10s. Okay, so I made 2 pairs of 10s. There are the 10s. And then this last little clump, 2 times 2 times 3, that will give me 12. And so my final answer is 1, 2, 0, 0 is the least common multiple of these 3 numbers. I don't want to add those as fractions. That would be a lot of adjusting, wouldn't it? Okay, so this is how we find the least common multiple. Ooh, exciting, last piece. When we have pure numbers. But what if, oh wait, no, we just have one more of these. $43.3. I'm going to talk about letters in 43.4. John's going to drag us through some more big numbers. 560, 588, 1250. Oh my gosh, John, these numbers are tremendously huge. All right, well, we just break it down as best we can. And so we start by just going, okay, what are any 2 numbers that will multiply to equal this? If it's an even number, you can do 2. It's totally fine. But I see the 0 here, so I go, okay, let's do 56 and 10. Right? This is 8 times 7. 7's prime. 8, oh yeah, that's 2 cubed. So I'm going to write that out. And then 10 is another 2 and a 5. So the prime factors of this beast are 2 times 2 times 2 times 2, 1, 2, 3, 4, times 5 times 7. And sometimes it helps to cross them off as you add them to your list. Okay, let's try this one. Let's use the 2 trick, right? So I'm going to do it by 2, which I know is prime. Now I need to divide 588 by 2. Okay, 500 is going to give me 250, and then half of this is 44. So that tells me 294. Ugh. That's a big, ugly number. Let's break it down again by 2. This time I'll just do it by long division because I don't want to make a mistake. 1. I get the 9, 8, 14. So there's a 7, 147. Ay, ay, ay. That's not even anymore, so we can't divide by 2. It's not a 5, it's not a 10. What about a 3? Let's add together these digits. 1 plus 4 is 5. 5 plus 7 is 12. 3 goes into 12, so that tells me 3 is going to go into this. See, that's the problem with these problems, is that these numbers get big and ugly, and we just want to cry, right? All this guessing and divisioning is annoying. 4 times 3 is 12. Aha! 3 times 49 equals 147. And 49, I don't need to guess. I know my times tables. 7 times 7. So our prime factors of this one are 2 times 2 times 3 times 7 times 7. Whew. And we still have to do 1250. You see why this problem is annoying. I'm going to do 125 times 10. That 0 on the end is tempting me. 10 I know is 2 times 5. 125 is, I think in terms of money and quarters, it's 25 times 5, right? 5 quarters would give you $1.25. And then some more 5s. Okay, ready? 1, 2. I'm going to write them down a line. And then we have 1, 2, 3, 4 5s. 1, 2, 3, 4. Ugh! Isn't that annoying? Oh my gosh. All right. Another way that we can assemble our least common multiple is by going one digit at a time and saying who's got the most. So let's look at the 2's. 4, 2, 1. Okay, we need 4. We always have to take the most. Are there 3's? Yes, we have 1 3. Okay, he needs 1. 5's. 1, oh gosh, 1, 2, 3, 4. I'm going to have to start a second row. And 7's. 1, 2. So we need 2. We have to take the most of what anybody's got. Let me double check this. 4 2's. 1 3. 4 5's. And 2 7's. And do you know what that equals? If we multiply all of this together, it equals 1,470,000. That is a big flippin' number. If I was giving you this on a test, I would be perfectly happy with this as my answer. And this would be fine too, but I would not ask you to multiply all that. And in fact, if you ever were taking a test and you got a big chunk of numbers like that, it would be very smart to ask me, do you really want me to multiply all of this together? And I would either say yes, because it's not that bad, or no, please, for the love of God, don't do it. Okay, now I'm ready to talk about what if we're doing this with just not big, ugly, disgusting numbers, but letters. Find the least common multiple of 15 a squared b and 10 ab third to the third. All right? We're finding the LCM of this. All right? So we're trying to make a big number that both of these guys can find themselves in. Okay, so we could, if we wanted, we could break down these factors. This is 3 and this is 5. I'm getting a glare off my book. I hope you can see okay. This is 2 times 5. So to put this together, we're going to need 2 times 3 times 5. Everybody's got to find themselves. Now we go to the A's. Here's an A squared. Here's a plain A. We have to make sure that the bigger number is represented. And here we'll have to take the B cubed. And then when we simplify this, 2 times 3 is 6, times 5 is 30. A squared B cubed. Oh. Now, you may be able to find the least common multiple of 15 and 10 in your head. You may just think about it and go, oh, they both go into 30. That is perfectly fine. This process is super helpful when you don't have that moment of, oh, this is easy, I can do it. So I will always work it the slow way, but if your brain can see it, it's totally fine. Okay, 43.5. We're finding the LCM of 4x squared m and 6x cubed m. Okay, so again, your brain might be able to just look at that and come up with an answer. I'm going to break it down. 2 times 2, 2 times 3. So now my LCM equals, let's see, I need to have 2 2s and 1 3. That includes everybody. We take the highest exponents. Make sure I copied that right. I did. And this would equal, when I multiply through the numbers, 12x cubed m is our final answer. So what you can see very quickly after just doing a couple of these problems is that the numbers actually make it a lot more work. When we just have letters with exponents on them, it's super easy to compare and say, oh, for the LCM, we need to take the bigger of the exponents, right? When we're factoring, we have to take the smaller because they both have to give it to us. When we're creating the LCM, they both have to fit inside. Words don't really help this. I'm sorry. Sometimes I think the more I talk, the worse it gets. Okay, one more and then we're done. 43.6. Find the least common multiple of 12 x squared am squared and 14x cubed am to the fourth. Okay? Twelve is 3 times 4. There's the 3. 4 is 2 times 2. I can shortcut that one a little bit because I'm familiar with it. 14, 2 times 7, both prime. So I make my list. It's going to be 2 times 2 times 3 times 7. I don't need to add a 2. I've already got the 2's. And then let's look at these. M to the fourth, x to the cubed. I always prefer to go alphabetical. It just is so much easier. Okay, now we have to make sense of this number. Let's see, what if we just go 4 times 21? I can do that in my head. That equals 84. And then we'll write this in order. M to the fourth x cubed. When I compare this to John's answer in the book, he did not put these in alphabetical order. He left them in a mushy scramble. As long as we're multiplying things together, order doesn't matter, right? Because order doesn't matter in multiplication. 3 times 5 is the same as 5 times 3. So this is 100% fine. All right. This is the difference between greatest common factor and least common multiple. We use both of them a lot. I will try to use the words when we're working the problem so that you'll just hear them more and more and more and more, and the difference between the twos will soak into your brains. Okay, is there anything else I want to say? Oh, and don't be afraid of seeing the letters and the exponents because it's actually easier, right? Than breaking down those big icky numbers. This is nonsense. I don't want to do that. That's for like 6th grade. We're done with it. We don't need big, long, messy problems like that. Okay, 43 is over. Yay, goodbye.